All right, so the last two, in a circuit where the resistance is doubled and the voltage is quadrupled, what happens to the current? Okay, so now we're going to change both things, all right, and there's no number, so all you're going to really be working with is the coefficient, okay? So the resistance is doubled, okay, so that means that one's going to get a 2. The voltage is actually going to be quadrupled, that's going to get a 4. What's going to happen to the current? Okay, so if you think about it, right, the circuit is twice as hard to travel around in, but you're pushing 4 times as hard, right? So you're not only making up for the fact that the circuit is twice as hard to get through, you're pushing enough that that's also going to still make more charge flow. Okay, so 4 would have to equal 2 times 2. Okay, so even though it's a harder circuit to get through, you're more than making up for that by pushing 4 times as hard. Okay, so that was my unknown, so this should be 2 high, 2i, and then I guess I'll just put 2i because I didn't put any numbers in this one. Okay, because there's no numbers, so we'll just say 2i, it's doubled that it was before. Okay, so written when the voltage quadruples and the resistance doubles, the current will double. Okay. All right. And then you can come up with ways to represent these, maybe schematics, maybe graphs. Oh my God, I would love to see graphs. That would be great. This one might be a little hard to graph. Pictures, something like that. Okay. All right. Second one, 2 circuits are created. The first has a 12-volt battery. Okay. And a current of, 3 amps. Okay. So if V equals IR, I can see this is going to be 4 ohms. Okay, it doesn't really matter, but, we'll see. Okay, the second has a 6-volt battery. Okay, so that's going to be a reduction of a half. Okay, and the current is 6 amps, so I've actually doubled the current. Okay, so what's going to happen to the resistance? Okay, so if that's doubled, okay, and that is halved. Okay, so this one's a little bit trickier, right? So I have half is going to equal something, 2 times something. Okay, so what has to go here in order to make this side equal a half? Okay, so let's think about it. I'm not pushing as hard, but I have twice the current. What's going to happen to that resistance? Okay, if I have twice the current and I'm not pushing as hard, I want to think about 1/2 over here equals 2 times. This is going to have to be 1/4. Okay, it's going to have to be 1/4 because 1/4 times 2 is 2/4, which is 1/2. Okay, so look, if I'm not pushing as hard and I'm still getting more current, that circuit is super easy to get through now, right? It's a quarter easier to get through than it was before, so that's going to be 1 ohm, okay, which I can do here. 1/4 of the resistance, okay, 1/4 of 4 ohms is going to be 1 ohm. Okay, you might have to put it in like that when you type it in the box. Okay. All right, and you want to think about how does that make sense, right? Because I'm not pushing as hard and I'm still getting more current. That means that circuit is super crazy easy to get through. Okay, so when the current doubles and the voltage halves, okay, the resistance is quartered, right? It's quarter as easy. It's super easier than it was before. Okay, all right, and then see what you can come up with for these.